This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hi, everyone. I'm Jason Morgan, editor of Fleet Equipment, and welcome to Fleet Equipment Unscripted. Today, we're talking with Selda Gunsel, Vice President of Technology at Shell. Thank you so much for taking the time. I'm excited to talk to you today about some of the recent announcements that you've had on the wire.
Yeah, I'm very happy to be here, Jason. Thanks for the invitation.
So we're following up on an announcement about e-fluids, right? We write a lot about electric trucks. We talk a lot about electric trucks, but this was a new segment to me that Shell had made an announcement in. And so I really just want to kind of get your take, walk me through it, right? We talk about electric trucks. Obviously, the diesel engine is gone, so a lot of those fluids are gone. So what are e-fluids? What are the needs that are needed on the electric vehicles? And a lot of your announcements spoke to the grease. How are these greases different from what we're maybe commonly used to?
Okay, well, first of all, in order to enable energy transition to a low carbon future, the transport sector needs to decarbonize over the coming years. As you know, transport sector is accountable for more than 20% of global CO2 emissions today. And if we look at commercial road transport, that accounts for about 8%. So one of the solutions for decarbonizing transport sector is obviously electrification. Right. And however, the pace of electrification is different in different regions around the world, depending on regulations, incentives, customer preference, local resources, etc. And as you know, electrification is happening rapidly in light-duty passenger vehicles, but we are also seeing plans to electrify commercial vehicles, for example, in local last-mile delivery vans, such as the announcements we saw around Amazon. Right. But we also see global, heavy-duty OEMs, such as Volvo, Mack, Daimler, Detroit Diesel, making public announcements around their investments in electrification of heavy-duty trucks. So in order to service these vehicles, we have developed a specialized portfolio of lubricants, which we call e-fluids. They include greases, as you mentioned, but they also include transmission fluids, as well as battery thermal management fluids. And these fluids are specially formulated to improve reliability, durability, efficiency, and overall performance of electric vehicles. And the difference between e-fluids and conventional lubricants is that these lubricants need to operate in the presence of electrical components. Okay. So in addition to having good lubrication properties, they also have to have special characteristics, performance characteristics around electrical properties, conductivity, as well as compatibility with new materials used in high voltage electrical systems. So that's the main difference. Okay. In terms of greases, as you know, greases are used to lubricate wheel bearings as well as e-motor bearings. And these greases need to operate in, again, high speeds, high temperatures, and they need to be specially formulated to insulate the system against, voltage currents, because there is a phenomenon called dielectric breakdown of greases due to electrical charges that can actually cause damage to bearings. And I guess one additional property for greases in e-vehicles is that because these vehicles don't have engines, they are very quiet. So noise reduction capability of greases becomes an important performance characteristic as compared to, conventional diesel engines.
Right. Okay, so that makes a lot of sense. And honestly, I'll be honest, even from my side, the service aspect of it is still a bit unknown, right? Even how you work on the vehicles. Yes. To your point, the high voltage situations, and also talking about, okay, well, electric vehicles will have reduced maintenance, so maybe you won't see them as much, right? And how does that impact the fluids and the greases and the lubrications when it's not in the shop all that much? So what have you seen in development and testing of these? What were some of those major concerns on both the high voltage electrification side and maybe some of the longevity, durability side that you're trying to tackle there?
Yeah, excellent question. I mean, all of the e-fluids, whether they are transmission fluids or greases, need to be designed for longevity because they are really, one fill service for life. They have to be able to maintain their optimum performance throughout the life cycle of the vehicle, and they operate in sealed systems. So, the technical challenge that we see in developing these fluids is that you really need to balance wear protection with material compatibility. Again, material compatibility becomes really important because we've done a lot of field trials and we've seen that, if the lubricant is not compatible with the system, the electrical system, you can get a lot of corrosion. And, corrosion can actually damage the electric motor, which can then break down the entire vehicle. So we have to, balance wear protection, good lubrication properties with compatibility. Again, it includes copper corrosion. These electric motors operate at very high speeds, so foam control becomes really important. Okay. And again, overall stability and electrical conductivity becomes important. I think in transmission systems, we are seeing really interesting developments. In electric drives, you see systems where e-motor is integrated into the gearbox. So the transmission fluid not only needs to act as a lubricant, but it also has to act as a coolant in the system. So again, this requires additional performance characteristics from the traditional lubricants that we see.
Right. No, and it's interesting because I guess even on my side, talking about how, a lot of the overall bullet points of being simpler systems, the electric motors are a little simpler, but there's still a lot of details that fleets need to pay attention to in terms of those details to make sure that they're, one, just operating safely, right? And then still make, to your point, the protection, the wear protection and the efficiency there to make sure the equipment runs well.
Yeah, exactly. Because, currently electric vehicles really rely on fluids that are developed for internal combustion engines, right. Which means, they are not really optimized for performance. And that's our, aim here in developing e-fluids. We want to have dedicated, specialized fluids that can last, over the lifetime of the vehicle, that has good electrical conductivity and compatibility with the system. And I think the other point I'd like to make is around thermal management of batteries. We've developed a novel approach to thermal management of batteries because battery life and thermal management is a big design challenge for OEMs. Batteries can only operate within a narrow temperature range. Mm-hmm. And so being able to control, thermal spikes in batteries is really important. So we developed a system where you can actually immerse the battery in a coolant fluid, which we call immersive cooling, which can really improve efficiency and, the life of the battery. So that's another, cool technology that we are developing and testing currently with global OEMs.
Oh yeah, okay. So that's interesting. So like within the housing on the vehicle, it can be submerged within the. Oh, okay, yes. Interesting. Because we talk a lot about charging management and charging strategy to prolong the battery life, but you bring up a really good point here, even just on the maintenance and operations side.
Exactly.
Okay, interesting. Sorry, I had like 1 million more questions that I'll have to call you again based on battery management, but very interesting. When you, and I think to the point too of understanding that you pointed out that orders have opened for electric vehicles, especially on the heavier duty side. We're not quite in Class 8 here Yeah, some applications it's a lot in the 6, 7 range as well, but making sure that we're paying attention to these details because if you make an investment like that, you've invested in the infrastructure as well, probably at your location. You can't just start throwing your old heavy duty diesel greases on it. You want to make sure you're putting the right lubricants for the right application there.
Exactly. I think, our ambition is really to develop, as I said, dedicated e-fluids designed to meet the evolving need of electric vehicles. We believe that lubricants have a significant potential to improve efficiency of the vehicles, reduce maintenance, and we are working closely with OEMs around the world to co-develop or co-engineer solutions because each OEM has a different design. So I think we get better performance if we can co-engineer the hardware and the fluid solutions together, through a systems approach. And maybe one other thing I should mention is that our e-fluids are based on our unique gas to liquids technology. Gas to liquids allow us to start with natural gas and convert it into, high quality hydrocarbons. So we can molecularly engineer a hydrocarbon to have the, ideal properties for e-fluids. So that's another unique aspect of our new e-fluids portfolio.
No, yeah, definitely interesting and a little even above my head in terms of when you start getting the formulations because it does get so specific. I think we've talked a lot about it here, but I have to ask kind of directly. I mean, Shell is a name that we know is synonymous with the diesel engine, combustion engine, big player in that world. As we're moving into this electromobility landscape, where do you see Shell fitting in? I mean, we've talked a lot about the lubricants here and the fluids that are needed, but broad picture, what's your take on what's developing right now?
Yeah, excellent question. Our purpose as Shell, as a global energy company, is to power progress together with our partners so we can offer more and cleaner energy solutions. Our goal is really enable energy transition to a low carbon future. Now, providing more energy while reducing environmental stress on our planet is a huge challenge. However, we as Shell are committed to addressing this challenge, and we've made our commitment public recently by announcing that our ambition is to become a net zero emission energy business by 2050 or sooner. Now, from a technology perspective, there is really not a single solution or a silver bullet to achieve this ambition. Solutions will include a range of options, such as, improving the efficiency of the energy we use today, or replacing energy products with low carbon alternatives, such as biofuels, hydrogen, renewables, and electricity. And lastly, removing carbon from the atmosphere through carbon capture technology or nature-based solutions. So, as Shell, we are investing in all of these areas, working on developing solutions for all of these areas, because as I said, there is not a simple, technical innovation that can enable energy transition. In terms of e-mobility, as you know, I mean, we are seeing more and more, electrification. I think in the passenger car space today, the EV sales share is around 2.5% of the global fleet. This is expected to go up to 15% by 2030. And in the heavy duty segment, again, we are seeing a lot of activity. And I must say, China is leading this space because of the more stringent, government regulations around new energy vehicles and so forth. So, as Shell, we are really committed to investing in e-mobility. We have multiple pathways. We talked about specialized products for enabling efficient operations of e-vehicles, but we are also doing a lot of research, which you touched upon earlier, around fast charging of batteries. Because, as you mentioned, Shell is a leader in lubricants and fuels. In lubricants, we have been the market leader for the past 14 years. We work very closely with OEMs all around the world. So we know the new engine technologies, and we want to work together to provide most efficient solutions. in fuels, again, we have 45,000 fuel stations in 80 countries. We serve more than 30 million customers a day. So we have the ability, the scale to really enable electric mobility through offering charging services to trucks as well as passenger cars. So, I think our ambition as Shell is to be a leader in e-mobility, because we are really committed to leading and enabling energy transition, working with our customers and partners, and to decarbonize the transport sector. So that's how we see our role as a global energy player in the space.
Right. No, and there's a lot going on there. And on the infrastructure side, that sounds like a great way to turn that electric charging infrastructure from a problem to an opportunity really quick there. So very cool. Well, and on the technology side, it sounds like you'll be very busy for a very long time pulling all this off.
It's really exciting.
No, yeah, it's very cool. Even a lot of those technologies that you rattled off there, it was the first time I was hearing a lot of those too. So it'll be interesting to see what develops and what comes down the line. I really appreciate you taking the time to talk with us today. I know there's a lot going on, but it really gave me a better sense for the importance of paying attention to these details in electrification.
Thank you, Jason. It's been a pleasure to talk to you, and really happy to continue our dialogue in this evolving space, over the coming months and years. So thank you for the opportunity.
No problem. I'm sure I will be bugging you again soon with another rundown of questions.
I'm looking forward to that.
Take care.
Thank you.